Antares. Antares, known during early development as Taurus II, is an American expendable medium-lift launch vehicle, MLV, developed by Orbital Sciences Corporation with financial support from NASA under the Commercial Orbital Transportation Services, COTS, program awarded in February 2008. It was developed alongside Orbital's automated cargo spacecraft, Cygnus, which also received COTS funding. Like other orbital launch vehicles, Antares leveraged lower-cost, off-the-shelf parts and designs. Since 2018, the rocket has been manufactured by Northrop Grumman Corporation. The first stage is liquid-fueled, burning rocket propellant 1 or refined petroleum 1, RP1, kerosene, and liquid oxygen, LOX or LOXygen. As Orbital had limited experience with large liquid stages, construction was subcontracted for all versions of Antares. The 100 and 200 series were built by the Ukrainian companies Pivden Design Office and Pivdenmash, previously as Yuzmash, using refurbished Nk-33 engines from the Soviet N-1 program on the 100 series and newly built Russian RD-181 engines on the 200 series after the loss of an Antares 130 vehicle in 2014. After Russia's 2022 invasion of Ukraine ended access to these suppliers, Northrop Grumman Corporation announced the 300 series, with a first stage developed by Firefly Aerospace Incorporated. Firefly, based on the company's MLV rocket using composite structures and 7 Miranda engines to increase payload capacity. The second stage is a solid fuel motor from the Castor 30 family, derived from the Castor 120 used on the Minotaur C, Minotaur Commercial, formerly known as Taurus or Taurus XL, and ultimately from the LGM-118 Peacekeeper, originally known as the Missile, Experimental, MX, Intercontinental Ballistic Missile, ICBM, first stage. While an optional third stage is offered, it has never been used, as the Cygnus spacecraft incorporates its own service module for orbital maneuvers. Antares made its first flight on April 21, 2013, launching the Antares A1 mission from Launch Pad 0A, LP-0A, at the Mid-Atlantic Regional Spaceport, Mars, with a Cygnus mass simulator. On September 18, 2013, it successfully launched Orbital D1, also known as Orb D1, the first Cygnus mission to rendezvous with the International Space Station, ISS. After completing the 2 COTS demonstration flights, Antares and Cygnus were awarded 2 Commercial Resupply Services, CRS, contracts covering 25 ISS cargo missions. The COTS program also supported the development of SpaceX's Dragon spacecraft and Falcon 9 rocket, intended to foster a competitive commercial spaceflight industry. Unlike Falcon 9, which has secured a broad commercial launch market, Antares has been used exclusively for NASA cargo missions, with Cygnus as its sole payload. As the Space Shuttle program neared its end, NASA sought to develop new capabilities for resupplying the International Space Station, ISS. Departing from the traditional model of government-owned and operated spacecraft, the agency proposed a new approach: commercial companies would operate spacecraft, while NASA would act as a customer. To encourage innovation, the National Aeronautics and Space Administration, NASA, offered funding through the Commercial Orbital Transportation Services program to support the development of new spacecraft and launch vehicles. On February 19, 2008, NASA announced that it would award Orbital Sciences Corporation a COTS contract worth $171 million. Orbital was expected to invest an additional $150 million, divided between $130 million for the rocket booster and $20 million for the spacecraft. As part of the COTS program, Orbital would be expected to conduct a successful demonstration of its rocket booster and spacecraft. If both demonstration flights were successful, Orbital would be eligible for a lucrative commercial resupply service contract of $1.9 billion for 8 flights to the ISS. In June 2008, it was announced that the Mid-Atlantic Regional Spaceport, formerly part of the Wallops Flight Facility, WFF, in Virginia, would be the primary launch site for the rocket. Launch Pad 0A, previously used for the failed Conestoga 1620 rocket, would be modified to handle Antares. Wallops allows launches which reach the International Space Station's orbit as effectively as those from Cape Canaveral, Florida, while being less crowded. The first Antares flight launched a Cygnus mass simulator. On December 10, 2009, Alliant Tech Systems Incorporated, ATK, test-fired their Castor 30 motor for use on the second stage of the Antares rocket. In March 2010, Orbital Sciences and Aerojet completed test firings of the AJ-26 engines. Originally designated the Taurus II, Orbital Sciences renamed the vehicle Antares, after the star of the same name, on December 12, 2011. As of April 2012, development costs were estimated at $472 million. On February 22, 2013, a hot fire test was successfully performed, the entire first stage being erected on the pad and held down while the engines fired for 29 seconds. The first stage of Antares burns RP-1, kerosene, and liquid oxygen, LOX. As Orbital had little experience with large liquid stages and LOX propellant, the first stage core was designed and is manufactured in Ukraine by Pivden Design Office and Pivdenmash and includes propellant tanks, pressurization tanks, valves, sensors, feed lines, tubing, wiring and other associated hardware. Like the Zenit, also manufactured by Pivdenmash, the Antares vehicle has a diameter of 3.9 meters, 150 inches, with a matching 3.9 meters payload fairing. The Antares 100 series first stage was powered by two Aerojet AJ-26 engines. These began as Kuznetsov NK-33 engines built in the Soviet Union in the late 1960s and early 1970s, 43 of which were purchased by Aerojet in the 1990s. 20 of these were refurbished into AJ-26 engines for Antares. Modifications included equipping the engines for gimbaling, adding United States electronics, and qualifying the engines to fire for twice as long as designed and to operate at 108% of their original thrust. Together they produced 3,265 kilonewtons, 734,000 pounds force, of thrust at sea level and 3,630 kilonewtons, 816,100 pounds force, in vacuum. Following the catastrophic failure of an AJ-26 during testing at Stennis Space Center, SSC, in May 2014 and the Orbital 3, also known as Orb-3, launch failure in October 2014, likely caused by an engine turbopump, the Antares 100 series was retired. Because of concerns over corrosion, aging, and the limited supply of AJ-26 engines, Orbital had selected new first-stage engines to bid on a second major long-term contract for cargo resupply of the ISS. After the loss of the Antares rocket in October 2014, Orbital Sciences announced that the Russian RD-181, a modified version of the RD-191, would replace the AJ-26 engines on the Antares 200 series. The first flight of the Antares 230 configuration using the RD-181 engine launched on October 17, 2016, carrying the Cygnus OA-5 cargo to the ISS. The Antares 200 and 200+ first stages are powered by two RD-181 engines, which provide 440 kilonewtons, 100,000 pounds force, more thrust than the dual AJ-26 engines used on the Antares 100. Orbital adapted the existing core stage to accommodate the increased performance in the 200 series, allowing Antares to deliver up to 6,500 kilograms, 14,300 pounds, to low Earth orbit. The surplus performance of the Antares 200 series will allow Orbital to fulfill its ISS resupply contract in only 4 additional flights, rather than the 5 that would have been required with the Antares 100 series. While the 200 series adapted the originally ordered 100 series stages, KB Pivden-Pivdenmash, Zenit-derived, it requires under-throttling the RD-181 engines, which reduces performance. The Antares was upgraded to the Antares 230+ for the NASA Commercial Resupply Services 2, CRS-2, contract. NG-12, launched November 2, 2019, was the first NASA CRS-2 mission to ISS using the Antares 230+ upgrades. The most significant upgrades were structural changes to the intertank bay, between the LOX and RP-1 tanks, and the forward bay, forward of the LOX. Additionally, the company is working on trajectory improvements via load-release autopilot that will provide greater mass-to-orbit capability. In August 2022, Northrop Grumman announced that it had contracted Firefly Aerospace to build the 300 series first stage. They will also be collaborating on the in-development Eclipse launch vehicle. Eclipse and the Antares 300 series will use the same composite structures, and 7 Miranda engines. The 7,200 kilonewtons, 1,600,000 pounds force, of thrust they provide will be substantially greater than that of the previous 200 series first stage. Northrop Grumman indicated the new first stage will substantially increase the mass capability of Antares. The announcement occurred as a result of the 2022 Russian invasion of Ukraine, which jeopardized supply chains for the previous first stages, which had been manufactured in Ukraine and used RD-181 engines from Russia. The second stage is an Orbital ATK Castor 30 series solid fuel rocket, developed as a derivative of the Castor 120 solid motor used as Minotaur C's first stage, itself based on an LGM-118 Peacekeeper ICBM first stage. The first 2 flights of Antares used a Castor 30A, which was replaced by the enhanced Castor 30B for subsequent flights. The Castor 30B produces 293.4 kilonewtons, 65,960 pounds force, average and 395.7 kilonewtons, 88,960 pounds force, maximum thrust, and uses electromechanical thrust vector control. For increased performance, the larger Castor 30XL is available and will be used on ISS resupply flights to allow Antares to carry the enhanced Cygnus. The Castor 30XL upper stage for Antares 230 Plus is being optimized for the CRS-2 contract. The initial design of the Castor 30XL was conservatively built, and after gaining flight experience it was determined that the structural component of the motor case could be lightened. Antares offers 3 optional third stages, the bipropellant third stage, BTS, a Star 48-based third stage and an Orion 38 motor. BTS is derived from Orbital's Geostar, a spacecraft bus and uses nitrogen tetroxide and hydrazine for propellant. It is intended to precisely place payloads into their final orbits. The Star 48-based stage uses a Star 48BV solid rocket motor and would be used for higher energy orbits. The Orion 38 is used on the Minotaur and Pegasus rockets as an upper stage. The 3.9 meter, 13 feet, diameter, 9.9 meter, 32 feet, high fairing is manufactured by Northrop Grumman Corporation of Aoka, Mississippi, which also builds other composite structures for the vehicle, including the combined fairing adapter, dodecagon, motor cone, and interstage. On January 14, 2016, NASA awarded 3 cargo contracts via CRS-2. Orbital ATK's Cygnus was one of these contracts. According to Mark Pichinsky, Orbital ATK Vice President, Flight Systems Group, a further improved version of Antares for CRS-2 contract is in development which will include Stage 1 core updates including structural reinforcements and optimization to accommodate increased loads. Also, certain refinements to the RD-181 engines and Castor 30XL motor, and payload accommodations improvements including a pop-top feature incorporated in the fairing to allow late Cygnus cargo load and optimized fairing adapter structure. Previously, it was understood that these planned upgrades from the Antares 230 series would create a vehicle known as the Antares 300 series. However, when asked specifically about Antares 300 series development, Mr. Pichinsky stated that Orbital ATK has not determined to call the upgrades. We are working on a 300 series. This is still TBD. In May 2018, the Antares program manager Kurt Eberly indicated that the upgrades will be referred to as Antares 230+. Use of Antares 330 for future CRS flights was confirmed in reporting from Breaking Defense in June 2024. The 330 will use the same second stage, fairing, avionics and software as prior versions. The first 2 test flights used a Castor 30A second stage. All subsequent flights will use either a Castor 30B or Castor 30XL. The rocket's configuration is indicated by a 3-digit number, the first number representing the first stage, the second the type of second stage, and the third the type of third stage. A plus sign added as suffix, fourth position, signifies performance upgrades to the Antares 230 variant.